So in chapter 6, we're looking at polynomials, and there's three different things we're looking at in this chapter. But first, we're going to look at just some basic exponent rules. Okay, so all of this is review, but these are just some rules that we're going to go through. There's not a whole lot to write down here, but it's just going through what each of these things mean. So when you have a power, it just means you're multiplying that item that many times together. If we are multiplying two items like this, we end up adding the exponents. If you jump down to this one, we don't add here. This is where we would multiply the two numbers in the exponents, okay, the r times the t. A negative exponent means it's flipped to the bottom. Anytime you have parentheses, you need to raise everything in the parentheses to that power. Anything to the 0 power is 1. When you're dividing, you're subtracting the exponents. And then these two are, this one I already talked about, and then this last one, if you have parentheses, just make sure everything gets raised to that power. So we're going to use these rules right here to simplify a bunch of polynomials. Right here. All right, so what we're going to do is look at each of these, figure out if we're going to add the exponents, multiply the exponents, subtract them, do all of that. Okay, so looking at this first one, we want to multiply the things that are alike. Okay, so we're going to multiply the numbers together and then the letters together. So what would our number be in the front? Yes, -8. Okay, how many a's do we have now? Is it 5 or is it 6? They're on the same level, so we're going to add them. If we have a power and we raise it to another power, that's when we multiply. So we have 5 right now. How many b's do we have? 2. So you just add the exponents. Okay. The next one. When we're dividing the numbers. So we have what number in the front? We really have 6. Okay. On the top, the easiest thing to do is think about how many can we cancel out. So how many could we take away from the top and the bottom? 1 from each, right? So we have 3 left over, and are they on the top or the bottom? Well, there's more on the top, so they are left on the top. So there's 3 left over. We canceled 1x from each. Okay, what about the y's? We can take away how many? We can take away 2 from here and 2 from here, which means we're left with y to the 3rd. There's nothing else to simplify at this point. Okay, the last two we have parentheses, so we need to make sure we raise every single thing in their numbers and letters, raise them to the power on the outside. So let's just do that first. We have 2 to the 3rd power and a to the, this is where we multiply. So now we have a to the 6th. And then we have 3 to the 3rd power, b to the 3rd power. So now let's just change these numbers in the front to what they actually are. What's the top one going to be? 8, A6, 27, B3. Questions? Okay, we need to take everything to the 3rd power. So we need 6 to the 3rd, g to the 15th, h to the -9. Okay, 2 things to do. We need to write what this number is, and then what happens to the h? It moves. Anytime you have a negative exponent, it's going to move either to the top or the bottom, opposite of where it's at right now. Okay, so 6 to the 3rd power is what?
216.
So we have 216 g to the 15, and the h got moved down to the bottom because it had a negative exponent on it. So that negative exponent means you move it. Questions on that piece of it? So we're good? Okay, last slide then. Let's practice simplifying. So not just a single term, but actually combining like terms. So again, this is review. But when we have this and we have a subtraction in between, we've dealt with this multiple times this year, we have to make sure we subtract both items in there. Okay? So if we do that, how many b squareds do we really have? We've got 3b squared because we have 7 minus 4. Okay, and then we've got what next? Yeah, the 6b doesn't get combined with anything else because there's no other b term. And then we have what? Should be minus 5 because we take negative 7 minus negative 2. We get negative 5. And that's it. Okay, what are they asking us to do here? What's the math word that we would do? We are going to distribute. So we get what? Plus 4xy. Okay, we just multiply here, multiply here. Okay, this last one here. I'm going to close this so that I can extend the page down here. What do they want us to do over here? I heard somebody say the window. We need to do the window. Okay, but it's not going to be a square, it's going to be a rectangle because there's 3 terms on one and 2 on the other. So we'll make a grid here. So we've got a plus b, and then we've got a to the third, 3ab minus b squared. And we're just going to multiply for each square on the inside, and there will probably be some like terms we can put together. So what's going to be in the first one?
A to the 4th.
And let's go across the top. This will be what? Three a squared b. Okay. This one? Negative ab squared. Okay. This one? Negative b cubed. Now, the nice thing about putting all of your variables in alphabetical order is it's easier to see when you have like terms. Do we have any like terms here? We have one, correct? Right here. Are there any other like terms that match exactly? No. Okay, so we can put those two together. So it doesn't matter what order you list them in. I usually just tend to go across the top row and then the bottom row. So we've got a to the 4th minus 3a squared b. And then what is this term going to be? When we put those two together that I circled. If we had negative 3x and negative x, and we combine them, what would it be? Let me write it right next to it. If you were going to combine like terms, what would that be? This would be negative 4x plus 5. Yes? So knowing that, this would be negative 4ab squared. Then we've still got this one, plus a cubed b minus b cubed. From these two together, combining like terms. This is really a negative 1. Questions on that? I just got one thing left to look at. All right, so let's take a peek at this. So monomials they have exponents that are positive integers, and polynomials are a bunch of monomials. Okay, so the exponents need to be what, according to what I typed up there at the top? They have to be positive and integers, which means what? Yeah, there's no fractions or anything, okay? So state whether the following are polynomials and what the degree is. So first of all, let's just talk about whether it's a polynomial based on the rules up at the top. So is this first one a polynomial? How come? Okay, what has to be non-fraction? So read at the top here. Exponents are positive integers. Are exponents positive integers?
Oh, it's negative 8.
Are the exponents, which ones are the exponents, guys? There's 3 exponents up there, right? What are they? 3, 4, and 5. Those are the exponents? Are they positive? Are they integers? Yes. So this is a polynomial. Okay, we don't look at the 1/4, we don't look at the negative 8. We're looking at the exponents. So it is a polynomial.
We solve it?
Nope, we're not solving it. So we answered the first one, state whether the following is a polynomial. So it's yes. What the degree is. Now the degree is the highest number exponent on the terms. So if we look here, how did they get 7 for the degree? Where did the 7 come from?
X cubed plus x5? No.
We have one term right here, and we have one term right here. Where did the 7 come from? 3 plus 4. Okay, so you pick the term that would have the highest exponent value if you added the exponents together. That is the degree of the polynomial. Okay, so looking, yep.
What about 3 plus 5 or 4 plus 5?
Those are on separate terms. You pick the single term that has the highest number when you add them together. Okay, so what about this one? Also know that this right here, remember when we did this, what number is really out here? There's a 2 out here, and there's really a what exponent here? So how did we change these when we had this? Have we talked about this? No?
X squared?
This is the same thing as this right here. Okay, the 1 and the 2 become a fraction. So is this a polynomial? No. How come? Because there's a 1/2. Yep, so the 1/2 makes it not a polynomial. Okay, and the last one. Yes or no, polynomial? No. What makes it not?
-3.
The -3 makes it not a polynomial. Questions?